Hello, and this time I'm going through some binomial expansion questions. These are some pretty tricky questions, so I'm assuming that you can already take a bracket like x plus y to the power of 5 and expand it. So you'd have the x to the power of 5 first, all to the power of 5, and then you'd have one fewer x's, x to the 4, and one y, and then you'd have a one fewer again, but one more y, and it sort of goes down like this until you've just got all the y's at the end. And of course you have the coefficients in front from Pascal's triangle. So you always start with a 1, you always start with n, so that's going to be a 5, and it's symmetrical, so we know it's going to end with a 1 there and a 5 there, and then these intermediate terms you can find with the NCR button on your calculator. And there is a formula for that. It is n factorial over r factorial n minus r factorial, but unless you need to use that because you're told something specific about, you're not told the power maybe, or you're not told which term it is or something, so you don't know what n and r are, then if that's the case, yes, fine, but otherwise just use that in the calculator. It's not something that, you're going to get bonus points for doing it manually. Okay, I'm just going to dive straight into doing these questions. So first of all, let's look at the bronze. If I can turn the page, there we go. So we've got this not very nice looking question because it's not just a binomial, but it's got an extra linear bracket to expand with it as well. So the first thing we're going to do is, read the question. It says that it's told us what the expansion up to x squared is, but it's got two unknowns, a and b. And then they've been nice with this question. They've structured it. So they've said, okay, first thing you do is just work out what the first three terms of the expansion of this is. So we'll do that. First thing we get is 1 to the power of 4. I'm just going to do all the brackets and all the powers, and then I'm going to do the coefficient afterwards. So plus, and then I'm going to get 1 to the power of 3 and minus 5x to the power of 1. And then the next term I'm going to get, put that plus closer to there, I'm going to get 1 squared, and I'm going to get minus 5x squared. Now the coefficients, I know the first one is 1, so I'll leave that. The second one will be 4, because it's always n. And the next one, I don't know what that's going to be, but if I reach my calculator, my on-screen one isn't working particularly well, but I'm going to type in 4 for n, press the NCR button, which for me is above my divide button, so shift divide, and then for r, I want this term, and r is either of these two powers. That's what r is, so it's 2. Okay, it doesn't matter which one you use because it's symmetrical. So here you could use 3 or 1, it'll tell you 4, and the next term, well, those numbers swapped over, but again, it'll still be 4 because it's symmetrical. So 4C2, and it tells me it's 6. I'm going to expand that because it wants it in its simplest form. So I get 1 minus 20x plus, well, that's going to be 25 times 6. So that's going to be 150x squared. And that's it. Let's put that squared a bit better. There we go. Not that much better. There we are. Write down the value of a. Well, write down normally means no calculations needed, but it's not this number 1. Because remember, what we've got is this a minus 37x plus bx squared is the expansion of this thing, not what I've just worked out. I've only worked out the power of 4 bit. I've still got a 2 plus kx. But the only way to get the the constant term a is to have the 2 times the 1. Anything else is going to have an x in it. So a is really easy because it's just these two things times together. So it's 2. That's it. Find the value of k. Well, we know the coefficient for x, it's minus 37. And there's 2 ways to get a linear coefficient, linear terms out of this, which is the 2 times the linear, which will give us minus 40x, and the linear times the number, which give us plus kx, and we know that this equals minus 37x. So we can just get rid of all the x's and just say that k minus 40 equals minus 37, which means k equals 3. Probably going to have to delete this one, so I've got space to work out b, but hopefully you can, I'll leave it up just for a second longer. You can see that I've just taken the coefficient of that, worked out what the x term might be from the various combinations. There's only 2 ways to do it. because this has only got two things in it, and then I've just made the coefficients equal in order to work out what k is. Okay, so for part B, now we know what k is, we can look at the x squared term to get b, so we know that it's b there. And here there's two ways to get the b term, the x squared term rather, which is the 2 times the x squared, so that will be 300 x squared, but also the x term times the x term, so that'll give us x squared, so that's minus 20k x squared. And this is going to be the same as the bx squared term, and without the x squareds, just looking at the coefficients, equating coefficients, then we get this. And we know what k is, it's 3, so this is just 300 minus 60 equals b, therefore b equals 240. And we've got our three answers, 2, 3, and 240. Okay, moving on to our silver question. The silver question is almost identical. It uses a very similar function. All they've done is they've swapped the 1 and the 2 in the brackets, and this time they're giving no scaffolding. It's just a big old 7-mark question. It's very normal to get in an exam, and some people just, freeze at this point because they can't remember the steps, or they're not happy just to have a go and see what happens. So again, if I was coming to this fresh, having not done the previous one, obviously having done the previous one, we're just going to do the same thing. But if I was coming fresh to this, I'd be first thing I would be doing is I'd be expanding that bracket, because it's the only thing I know how to do. I can get somewhere doing that, so I'm going to do it. So this one's going to be a bit more tricky, but let's give it a go. Only because that's a 2, so we're going to have more numbers. But there we are. Let's do it. So up to the x squared term. So we've got 2 to the power of 4 plus, leave a space, 2 cubed times minus 5x plus, leave a little space, 2 squared minus 5x squared. Just check that all the pairs of power, so just 4 adds up to 4, 3 and 1, 2 and 2, all adds up to 4. And now we need to put Pascal on. That's a 1, so we'll leave that. That's a 4, and I could do NCR on the calculator, but from last time, that's a 6. We need to expand this, so we're going to get 16 plus, so 8 times 20. So what's that? 160, and it's minus as well, isn't it? Minus 160x plus, so we've got 4 times positive 25, so that's 100, so 600x squared. Okay, well, that's fine, but remember, that's not just a 36 and b. Indeed, the 36, the 64 doesn't line up. So this is all being times by 1 plus kx. So what is a? Well, a is nice and easy. It's 1 times 16. A is 16. Done. For, I think probably k is going to be the better one to work out now, just like we did last time. So we're trying to compare that to minus 64. I'm not sure I'd know that if I was doing this question having not done the previous one, but my next step would say, oh, well, I know what the linear term is, so if I equate the linear term here, I'll work something out, and then I'd obviously realise that that something was a k in a moment. So we know we've got the minus 64. How do we get the x term? It's going to be 16kx there, and it's going to be the 1 times the linear, so minus 160x. And we're saying that 16k minus 160 is going to be the same as minus 64. So 16k equals, so we have to do 160 minus 64, moving that across, so that's 96, and then divide that by 16 is 6. So now we've found the k, we can almost certainly find the b. Same thing as before, we're going to look at the x squared term, which we do by the constant term times the x squared term. So that is 600x squared. And the linear times the linear, which is minus 160kx squared. So we know that 600 minus 160 times 6 is going to equal just b, because it's just b there. So we just need to work out what that is. And if my brain was slightly less tired, I'd do that in my head, but it's not, so I won't. So we get the number of minus 360 equals B. B equals minus 360. So exactly the same method as before, but they didn't give us any scaffolding. We had to know that that was the method to use. And finally, the gold question, we've got same thing again, something with a binomial, but it's got a q in it, times by a linear with a p in it. We don't know what those are. The expansion is given up to the cubed term, and then again, no scaffolding, find the value of p and q. Well, it's the same method as before. We're going to do the expansions, and we're going to equate the coefficients. So let's start by just expanding the binomial term. So we've got 1 to the power of 5. That's supposed to be a bracket there. Plus, leave a space, we've got 1 to the 4 times qx, plus, leave a little space, 1 to the 3, and then qx squared, and then we need to go all the way up to x cubed, so we've got plus, leave a little space, 1 squared, and qx cubed. Just check they all add up to 5. They do. We need Pascal on this, so 1, then n, so that's 5, and then the calculator would tell us that this is a 10 and this is a 10. Or you might just know Pascal for the first few rows. Okay, but this isn't what we need, because remember, what they've given us here is the expansion of these two things times together. So, I should simplify this first, shouldn't I? So 1 plus, well, that 1 doesn't do anything, so plus 5qx plus, that 1 doesn't do anything, so 10q squared x squared plus, and that 1 doesn't do anything, so 10q cubed x cubed. And all of that is being timesed by 3 plus px. Now we need to find the values of p and q. Well, looking at the constant term isn't going to help, because we know that's 3, and it's not giving us p or a q in it. So let's make something out of the linear term, because we know that's going to be 17. So the linear term can be found by doing 1 times px, which is going to give us p for the coefficient. I'm not putting the x down, so I'm just doing the coefficient. And it can also be found as 3 times 5qx, so that's 15q, and that's just so no x, because we just want the coefficient, and that equals 17. Now that doesn't help because it's 2 terms, but maybe we can get another equation like that, and we can solve it simultaneously. Okay, and then I'm going to look at my x squared terms. How do I get x squared? I'm going to do my 3 times my x squared, which gives me 30 q squared x squared, plus, and then it's my linear times my linear, which is 5pq and x squared, but again I'm leaving that off, and this equals 70 over 30, 70 over 3, sorry, just from here. Now, not so nice, but because it's quadratic, but we've got an equation in p and q here and another one here, so I'm going to rearrange this. I'm probably going to say that p equals 17 minus 15q. I'm going to substitute that bracket in place for that p, and I'm going to expand it all. I'm going to rearrange it. I'm going to solve the 3-term quadratic, and I should end up with 2 values of q. And if one of them is negative, I'm hoping one of them will be negative, and then I can discount it because I'm told that they're positive up here. Now I'm not going to do that bit because that's just solving the quadratic. What I will do is just do the substitution. 30q squared plus 5q, 17 minus 15q equals 70 over 3. So what I personally would do is expand all this, simplify my q squareds together, times everything by 3, all the terms by 3, bring the 70 over, and then I just put it into the equation solving function on my calculator, the quadratic solving, and I just get the answers for q. One of them will be negative, so take only the positive one, and then put that positive one back into this equation and work out the value of p. And so once you've got those 2 values of p and q, then you've got 7 marks. Hence, find the value of k. Well, it's only worth 1 mark, so hopefully this should be quite easy. Well, k here is the x cubed coefficient. So again, we need to look at how we make x cubed. Well, it's going to be 10. Oh no, it's not going to be 10. Sorry, it's the number 3 times the x cubed. So it's 30 q cubed x cubed. But we're not going to write that down because we're just doing the coefficient. Plus, and then it's the x term times the squared term. So that's going to be 10p q squared. X cubed rather, but again we don't need the x bit, and this equals k. Well, now you know what p and q are, you can work that out quite easily. It says hence find, so there is a bit of maths to do. It's not like a write down, it's not an obvious, but that's the exact same method that we've been doing so far. So if you've got to part B, then you must know what you're doing, in which case that shouldn't be too hard. And then just substituting in your answers and you get the value of k. So it's not unusual for that to be, feels like quite a bit of work, but it's for 1 mark. That makes sense because they've already asked you to do a lot of that already. Hopefully that gives you a good understanding about how to solve these questions where you've got a bracket to a power times a linear with these 3 examples there. But if you have any questions, you can put them in the comments below. Ta-ra for now.